Hello everyone. Today we are discussing about the topic on MLOps and when do you transition your project into an MLOps model. So we are going to take the example of Titanic dataset in Kaggle. That's a very easy project to get started on and see how initially we will only be working in notebook. Then we will slowly start adding Python functions to help the notebook. And finally, how do you transition into MLOps when the project becomes more complex, right? So to give a brief, notebooks are excellent to get started, especially when you're visualizing the data. That's an excellent platform, and even to share your discoveries with other team members because of its note, visual as well as text parting, right? And the cells in it. Now, as such, notebooks are great. However, when you want to expose it as an API or build a project, I believe you transition into Python and start creating modules and functionalities or business logics around your models. Finally, you reach a stage where the data extraction part may become complex and you separate it out, and the other part is you want to regularly train your machine learning models. That could be the exact time where you transition into MLOps and add tools to help you with that transition. So there are two challenges which MLOps ideally could help us with. One, like we said, the data part, where you are pre-processing your data, cleaning, those steps can be put together and we can see it, visualize it, and understand it better, right? So once that stage becomes bigger, it is challenging to use just notebooks. And the second challenge is when you have different models, you want to do different experiments by adding new features, changing, you don't have a way to track them, and that is where the second challenge comes into. For this series, we will try to see two frameworks to help us with this, or tools. One is called Airflow, which is an ETL, and it has a wonderful UI so that you can see how your data transitions to different phases. Then you have MLflow, which is helps us track your models and have a common registry where you can store your models. So like I said, we are going for the Titanic data set. So to give a brief about the data set, at the end your objective is to classify whether a passenger will survive or not. And there are different features which are given based on the passengers who travel there, like their class, their sex, their age, whether they had siblings or parents with them, the ticket number, the fare, the cabin, and where they were going on this journey to. So, if you haven't worked on Kaggle, this is a wonderful data set to get started. And so basically, there are two parts in the data. One is the training, and one is a test data set. So we will see how you would have done it as a simple project with only notebooks. So that is where I have added this notebook called basic, where basically you are loading your data, you are dropping most of the columns which doesn't have full numerical values or have missing values, right? And then you are directly encoding the other string fields. Finally, you are splitting your data and training different models, right? Here random forest, here logistic regression, and the boost one. So this is a simple project with doesn't have any data transformation or different types of models, right? So in this case, notebook is a very good option to get started, and we are getting somewhat good accuracy also on the training data. Now imagine you want to take it one step further and do lot of data cleaning, pre-processing, and others. So let's say you move into the next phase where you load both of your data, you combine them so that you have more data. Then you are trying to identify the missing fields, and each of those fields you have unique logic to handle those missing values, right? So those kind of scenarios, we may write separate Python codes and have a framework around it to help us in this notebook. Right? So this could be your second phase. Right? And here I have gone way overboard. So you're trying to predict, I mean, first update each of those missing values with specific logics. For that I have a separate missing Python file, and then there is a feature engineering where you split the name. So to show you the name comes in three parts, right? So there's a first name, there's a title, as well as a last name. So we are doing a feature engineering, splitting your name into different parts. Then you are encoding the name, encoding the title. Again, you are doing some more feature engineering, right? For the age, rather than having it as a continuous value, you are creating bins out of it, and you're encoding some of these values. And even I think I went little overboard. uh, I created a separate machine learning model which can predict whether the deck number based on the cabin values, right? So almost 80% of the data set is missing here. So even if I'm trying to predict, it doesn't have much accuracy. But anyway, I just wanted to show what all are the different ways you can think of doing a feature engineering on the data. And one thing, even after doing all of that, my accuracy is not improving much. But this was just to show you how you would do a real world project, right? And another thing you would notice is our feature size has grown. I mean, the columns or the feature count has grown drastically. Now imagine maintaining these and trying to fine tune each of them. This is where I was saying the data challenge, right? Suddenly your data transformation is growing, and that could be a good example where you move into using Airflow. And in our next video, we will be seeing how to set up Airflow and make all our pre-processing, visualize it, as well as change some of those easily. Right now, imagine I want to change how I was doing the prediction. I have to scroll through it, see the function, go there and edit it, right? And finally I'm splitting the data and trying with random forest and some other um, models too. The accuracies are good. And finally, if you want to participate in the challenge, what you have to do is you have to create a submission.csv file with only the passenger ID and your survival prediction, right? Once you have created it, you can come here and you can upload the file, right? So these are my predictions. Now this comes to another second challenge, right? I tried different bunch of feature engineering, and I have models which have 78% accuracy and some less. Now all of these experiments which I ran, unfortunately the second time I run it gets overridden. So there is no way for me to track how each of those runs were and what was the artifact we are creating out of that. This is where MLOps comes into picture, so that you can track which was this model you built and what was its accuracy, what was its feature importance, all of those data. And even if you like that model, you can put it in your artifactory or your registry to store it for future usage. Okay. So these are the two second videos I'm going to make. One is on Airflow, how to process your data, and MLflow on how to track your experiments and create your machine learning model registry. Hope to see you there. Bye bye for now.